Hello everyone, welcome to this video. In today's video, we would like to write a program to check whether numbers in a vector can be rearranged so that each number appears exactly once in a consecutive list of numbers. Return true, otherwise return false. So first of all, we need to see if there are some duplicate numbers in the vector, and then to check if they are in a consecutive list or not. To do that, we need to navigate through the solution in 3 steps. First, we are going to sort the vector. It would be easier to check for duplicates if we are having a sorted vector. This is why we are going to sort it. Then we are going to check for duplicates, and then we are going to check for consecutive numbers. Okay, here is my program. This is the main function. I'm having a vector called nums, and it is of integer data type, and these are the numbers and elements of my vector nums. Okay, so 4, 2, 3, 5, and 6. So first of all, we need to sort this vector, then we need to check for duplicates, and then we need to check if they are in a consecutive order or not. Consecutive order means that, for example, after sorting this vector, we are going to have 2, 3, 4, 5, and 6. So they are in a consecutive list because we see no gap between the elements. If we had something like 2, 4, 5, and 6, for example, this was not a vector in consecutive order because we are missing one number here. 3 is missing, therefore there is a gap. In order to check if numbers are in a consecutive order or not, we need to first sort the vector and then check elements 2 by 2 to make sure that they are in a consecutive order. So this is an example of a consecutive ordered vector, this one, and then this one is an example of non-consecutive order, okay, because we are missing number 3 and there is a gap here. So I'm having my vector here, and then I would like to write a function to do the work for me. And basically, I'm having one if-else condition in the main function. So we are saying that if this function uh, that is called can form consecutive sequence, and we are passing this vector nums as the argument, if this function is going to find the answer true for us, if this function is going to return the answer true, we are going to enter this part. So we are showing this message true, the numbers can form a consecutive sequence. Otherwise, we are going to have this message saying that the numbers cannot form a consecutive sequence. But let's go and see what this function does. So when we have this if condition, the compiler is going to execute this function. So this function is here, and this is the function. The full function is here. The name of the function is this one, can form consecutive sequence. It is of Boolean type, so it is going to return a Boolean, so either true or false. Then it accepts one argument, and the argument is of vector type and integer. So the argument is vector of integer data type, sorry. Then we are using the const and call by reference. Why we are using the call by reference? Because we don't want to make a copy of the vector and then work with the copy. When we are having the call by value, we don't need to have this reference here in the argument of the function, and we are working with a copy version of the vector. But when we are having a call by reference, and this is the sign of the call by reference, we are having the AND operator here, okay? So when we are having it, we are going to directly work with the vector, okay? So it's a good way to save memory. But the thing is that we may accidentally going to make some modification to the original vector when we are using the call by reference, because call by reference is directly working with the original vector in here, okay? This is why I'm typing down the const keyword, making it impossible to modify the vector. So this is to ensure we are not going to accidentally modify the num vector when we are using the call by reference. Okay, so this function is having one argument. This is the name, and it's of Boolean type, so it is going to return either false or true. First of all, we check to see if this vector is empty or not. So if the vector is empty, we cannot work with it. This is something to just check. So we cannot work with a vector that is empty. And in case that the vector called nums is empty, return false. And in order to check if a vector is empty or not, we simply type down the empty in empty parentheses, and this is going to check for us. Okay. The first step is to create a copy of the vector and sort that vector. In order to create a copy of the vector, the original vector, we are going to declare and initialize a new vector called sorted nums. It's a vector of integer data type, and we are assigning the original vector nums, which is passed as an argument to this function. We are assigning that to our new declared vector here. So sorted nums is our new vector. We are copying it to a new vector because we don't want to mess with the original vector, and we don't want to do something with the original vector, and it is a bit consecutive way to work with the original vector. So I use the constant keyword to make sure I'm not modifying it, and I'm just making a copy of this vector to another vector, and I'm going to work with this vector that I feel safe about. Then, in order to use the sort function, we need to include this header. Just remember, you need to have the algorithm header. Then we use the sort, and we are going to type down the name of the sorted nums dot begin and comma and sorted nums dot end. So in order to sort a vector, we are going to use the sort function, and then there are two arguments in the parentheses, one before comma, one after comma. So the one that is before comma, I type down from dot begin. It means that I'm going to start sorting this vector from the beginning, and I'm going to continue until the end of it, which is on the right side of the comma. So now I'm having a sorted vector that is like this: 2, 3, 4, 5, and 6. Okay, so the original vector was 4, 2, 3, 5, 6. Now I'm having a vector that is 2, 3, 4, 5, 6. Now it's the time to check for duplicates and check for to see if numbers are in consecutive orders or not. To do that, I'm having a for loop. I'm having my iterating variable. It's of integer type equals to 1. And as long as this I is going to be lower than the size of my sorted vector, it is going to continue, and it is going to increase by one value in each iteration. Then we check this condition. Okay, we check if the ith element of the sorted nums vector equals to the sorted nums I minus 1 element. So let me type it down here. So basically it checks to see if number 3 equals number 2. Why? Because in the first iteration we are going to have sorted nums, okay, I equals 1 equal to sorted nums I minus 1, it will be 0. Okay, so it is going to check to see if the second element of the vector called sorted nums, which is this one. We are saying second element because the index is 1, and indexing in C++ starts from 0. Okay, so this is why we are checking this. Okay, so the index 1 element of the sorted num will be the second element, which is 3. It is checking if 3 equals to the first element of the sorted num vector, and the first element with index 0 is number 2. So it is checking to see if 3 equals 2. We are looking for duplicate elements, and in the next iteration it is going to check if 4 equals 3 and if 5 equals 4, and finally if 6 equals 5. As you see here, because we don't have any duplicates, neither of these conditions are true. Okay, and this condition is not true. Therefore, for any of the iterations in this for loop, this statement is not true because we checked it here. All the elements are unique and they are not duplicates. If one of the elements was equal to another element, it meant that we were having duplicates and therefore it was going to return false for us. Okay. This is the first if condition that we are having in the for loop. In the second if condition that we are having in this for loop is to check if numbers are in consecutive order or not. For example, it is saying in the first iteration, it says that if the second element of the sorted nums vector with index 1, it does not equal to sorted num with index 0. So it is checking to see 0 plus 1, okay? It is checking to see if one element minus 1 equals to the previous element or not. So in order to check if numbers are in consecutive orders, it means that they should be, for example, 2, 3, 4, 5, 6. And the difference between any two consecutive element is only 1. Okay? So we are checking to see, for example, here, I'm checking to see if number 3 does not equal to number 2 plus 1. Okay? Here is my sorted vector. Let me copy it here. When I copy it here. Okay. So this is my sorted vector. And these are the indexing 0, 1, 2, 3, and 4. Okay. So in the first iteration, when I equals 1, we are going to check if sorted nums with index 1 does not equal to sorted nums 1 minus 1 will be 0. Therefore, I'm going to type down 0 plus 1. It means that I'm talking about the index 1 of the sorted nums vector, and index 1 is number 3. So 3 does not equal to 2 plus 1. And this statement is not true because the left hand side equals the right hand side. If it was not, if this statement was true, we are going to return false. But this statement is not true, therefore we are not going to enter this if condition. Okay, because the left hand side is 3 and we are saying 3 is not equal to 3, and this statement is not true, therefore this statement is not true, therefore we are not going to enter this if condition, and therefore we are not going to return false. Okay, in the second iteration we are saying 4 does not equal 3 plus 1. Why I'm saying 4? Because 4 in the second iteration, I equals 2 and I equals 2 is the index 2 of the vector with the third element of the vector sorted nums, and number 4 does not equal to the previous element plus 1. Previous element plus 1 is 3 plus 1, and indeed 4 equals 4, and therefore this statement is not true, and therefore this statement is not true, and therefore we are not going to enter this if, and we are not going to return false. And we are going to continue saying that 5 is not equal to 4 plus 1, and this is not true again. 6 does not equal to 5 plus 1, and this one is also not true. If either of them was true, this statement was true, and we were going to return false, meaning that there was a gap between any two consecutive elements of this vector. For example, if we had a vector like 2, 4, 5, and we were checking one by one, we were saying 4 is not equal to 2 plus 1. Yes? So left hand side is 4 and the right hand side is 3. Therefore, this statement is true. It means that there is a gap between the two elements of my vector. It means that there was a gap there, and therefore because there was a gap, it means that we were not having all two consecutive elements in a consecutive order. So there was a gap there. Therefore 4 does not equal 3, therefore it was true, and if it was true, then this statement was true. Then we were entering this if and we were returning false, saying that okay, gap found and they're not consecutive. Okay, so this function is going to work for us like this. Let me review it one more time. So we are going to call this function with the vector argument called nums. So we are passing this vector as argument for this function. If this function is going to return true for us, we were saying that okay, the numbers can form a consecutive sequence. Otherwise, it was going to say the numbers cannot form a consecutive sequence. And this function, first of all, is going to check if the vector is empty or not. If the vector is empty, return false. So we are going to say the numbers cannot form the consecutive sequence. And then after checking if the vector was empty or not, we were going to create a new vector, assign the original vector to the newly created vector. Then we were sorting the vector. Then we were having a for loop here. And in the for loop, we were checking two things. Therefore, two if conditions were defined. In the first if condition, we were checking if we are having any duplicates. So we were starting from 1 and not 0. So we started from the index 1 of the vector. Therefore, we were starting from the element 2 of the vector, and we were checking element 3, element 2 and element 1, element 3 and element 2, element 4 and element 3 and element 5 and element 4. So 2 by 2 we were checking the elements because it's a sorted vector. We could do the 2 by 2 checking. So we were checking all two elements to see if we were having any duplicates or not. And in the first if condition, we checked the elements of the vector 2 by 2, and we saw that we had no duplicates because the elements are not similar. Therefore, we were not going to have this if condition to be true. The statement of this if condition was not true. Therefore, we were not returning false because there were no duplicates there. If there was any duplicate, this statement was true, and then we were going to have the return false. The second condition was to check if there is any gap between any two consecutive elements in the vector. To check that, we were checking all the elements 2 by 2, and we were seeing if the, for example, first element plus 1 equals the second element or not. So if it was equal to the second element, so the first element plus 1 equals the second element. If this statement was true, we were not going to enter this if condition. Therefore, we were not going to return false. Therefore, it meant that, for example, the first element plus 1 equals the second element, which is our case. The first element plus 1 equals the second element, okay? However, if the first element does not equal to the second element when it is added by 1, so we were saying that here, for example, the element 4 does not equal the previous element plus 1. Okay, we were saying 4, therefore 4 is not equal to 3, and this statement is true. When this statement is true, we are going to have this statement true, and then we are going to return false. So let me, before any further explanation, let me run the code. So when I run the code, it says the numbers can form a consecutive sequence. Why? Because this vector is sorted and it looks like this, and we see we are having no duplicates, and also we see that all the elements are in a consecutive order. It means that we are having 2 plus 1, the second element is 3. 3 plus 1, we are having the third element 4. 4 plus 1, we are having the fifth element, that is 5, etc. However, if we were having a vector like this, so 2, 4, 5, 6, so 2 plus 1 equals 3, and 3 is not equal to the second element. Therefore, there is a gap. So let me have this function here For example, 2, 4, 5, 6. So let me revise this vector. So when I have a vector like this, we are going to have this false statement being printed in the output. So when I run the code, it says the numbers cannot form a consecutive sequence. And the reason is 2 plus 1 is 3, and 3 does not equal to the next element, which is 4. Therefore, there is an error. So if I add 3 here and I have another 3 also, when I run this code now, it is going to still return false. The numbers cannot form a consecutive sequence because 3 plus 1 equals 4, but 4 does not equal 3 because we are having duplicates, and we were checking for duplicates here in this if condition. Therefore, this one also is not true. So basically, this is how we can have a vector. We sort it, we check for duplicates, and we check if they are having the consecutive sequence or not. Thank you for watching. Hello everyone, welcome to this video. In today's video, we would like to write a program that returns the elements in a vector that are strictly smaller than their left and right neighbors. An element is considered strictly smaller than its neighbor only if we are having this vector. For example, we are having 2, 3, 4, 5, 6, 7, and 9, for example, here. And instead of 5, let me put 0 here. So we are going to check if one element is strictly smaller than their left and right neighbors. So we are going to start from the second element with index 1 because it is the first element that has left and right neighbors. So number 3, is it smaller than 2? No. Is it smaller than 4? Yes. But we need to have an element that is smaller than both left and right neighbors. So we're going to use the AND operator. So can we say 3 is smaller than 2 and at the same time it is smaller than 4? No, this is not true because we are saying that 3 is smaller than 2 and 3 is smaller than 4. Okay, and in the AND operator we learned that both conditions must be true before the AND and after the AND. So these two conditions must be true at the same time. Okay, if we were having, for example, 3 smaller than 2 or 3 smaller than 4, yes, this condition, this statement is true because one of the conditions is true. Therefore, this statement could be true, okay? Because at least we need one condition to be true when we are using the OR operator. But when we are using the AND operator, here, when we are using the AND operator, both of the conditions must be true. Therefore, we cannot say that this element 3 is strictly smaller than its left neighbor and its right neighbor. We are using and even in this statement. Okay, therefore this is not true. And the same happens with 4. So 4 is smaller than 3. No. Is it smaller than 0? No. So 4 is not one of the elements that we need to return. But 0, it's smaller than 4, and at the same time it is smaller than 6. So 0 is one of the answer of this program. Okay, 6, is it smaller than 0? No. And at the same time smaller than 7? No. Therefore 6 is not one element that we are going to choose. The same thing goes with the 7. 7 is not smaller than 6, at the same time to be smaller than 9, so we are not going to have 7 in the output as well. So the only answer to this program is 0. Therefore, we are looking for elements that are strictly smaller than their left and right neighbors, like this 0 in this vector. Okay, so here is my vector in the int main function. Here is my vector. I'm having the vector called nums. We are having this vector 4, 2, 6, 1, 5, 0, and 8. With the same policy, if we want to analyze this vector, 2 is lower than 4 and 2 lower than 6. And then we are going to have 6 lower than 2 and 6 lower than 1. Then we are going to have 1 lower than 6 and 1 lower than 5. Then 5 lower than 1 and 5 lower than 0. Then 0 lower than 5 and 0 lower than 8. Okay, so this is how we are going to check elements one by one. So starting from the second element, we are checking to see if 2 is lower than 4 and it is lower than 6. Is it true? So 2 is lower than 4 and it is lower than 6. Therefore, it is true. So 2 is one of the elements that we are looking for. Then we are saying that 6 is lower than 2. 6 is lower than 2 and 6 is lower than 1. Neither of the conditions of the comparisons are true. Therefore, the answer is false and we are not looking for this element. So 1 is lower than 6, 1 lower than 6, and 1 lower than 5. So left neighbor and right neighbor. And this is true because both of the comparisons are true. 1 indeed is lower than 6 and it is also lower than 5. Therefore, this one is true. Therefore, another element that we are looking for in this vector is 1. And then we are checking 5 is lower than 1 and 5 lower than 0. It is false. And also here we are checking to see if 0 is lower than 5 and it is lower than 8. Yes, this is true. Therefore, this is another element that we are looking for. So the answer of this program is 2, 1, and 0. Okay, but how do we do it in C++ instead of doing it manually? In order to do that, we are having a vector called result of integer type, and the output of the find strictly smaller elements with the argument nums is going to be assigned to my vector called result. Okay, so we're calling this function and we are passing this argument, and this argument is nums, which is our original vector. So let's go and see what this function does. So this is the name of the function. This function is going to return one vector for us. Okay, the output of this function is return of integer type. So this is why the function, when it is called, the output is assigned to this vector, because the output of this function is a vector of integer type. And as the argument, we are having the vector in the argument. You see vector of integer type. We are having the call by reference because we don't want to make a copy of the vector and work with the copy. We are going to have the original vector to work with. This is why we are having the AND operator, which is a sign of using the call by reference. And I'm using the const keyword in order to make sure that I'm not going to modify by accident this vector, because we are using the call by reference. We are working with the original vector and we don't want to make any modification to that. Therefore, to be conservative, I'm going to use this keyword to make sure I'm not making any mistake and I'm not modifying the vector. So here I'm declaring a vector called result. It's of integer type, and we are going to have a for loop to check if elements are strictly smaller than their left and right neighbors. To do that, I'm having a for loop starting from 1, and we're going to continue this loop as long as I is lower than the size of the original vector that is passed to this function minus 1. And because we are not going to check the last element, and also we are starting from 1 because we don't want to start from the first element, because the first element does not have the left neighbor. So the first element that has the left neighbor is the second element. Okay, and we are going to continue until 1 to last number, because this is the last number. This one is also not having the right neighbor, so we want to end until we are going to work until this element 1 to end. This is why we are having the size -1, and I is going to increase by 1 unit in each iteration. And basically in iterations we are going to check if for example, the second element is lower than the first element and the second element again is lower than the third element. So basically, in the first iteration, when I equals 1, it means that nums 1 lower than nums 1 minus 1, which is 0. I'm going to type down 0. And nums 1 is lower than nums 1 plus 1 means 2, so I'm going to type down 2, okay? And this vector, we know the index. So let me type down the index here. So here, this one is 0, 1, 2, 3, 4, 5, and 6, okay? And in this for loop, we are going to start from the index 1, and we are going to continue until index 5. And here I'm checking the index 1 of the nums vector, which is number 2, is lower than the index 0 of this vector, which is 4. And 2 also is lower. Okay, 2 also is lower. The index 1, which is 2, is lower than the index 2, which is number 6. This is true. If this condition is true, we are going to enter this if statement, and we are going to push back that element of the nums vector into our result vector. So now the result vector equals 2 after the first iteration. Okay. In the second iteration, it is going to compare 6 with 2 and 1. So 6 is lower than 2 and 1, no. So when the answer is no, this statement is not true. Therefore, we are not going to enter this if condition. Then it is going to compare 1 with 6 and 5. So 1 is lower than 6 and 5, yes. When the answer is yes, it means that this statement is yes and this statement is true. Therefore, we are going to enter the if condition, and we are going to use the pushback function to add the if element of that num vector to the result vector that we declared here. And this if element means, for example, when we are having the nums, for example 3, which is the third index of the element with the third index with the index 3 of the vector nums, which is number 1. Therefore, number 1 is also added to this vector. And finally, we check the 5, it's not true. And then we check the number 0. 0 is lower than 5 and 8. Yes, so we are going to add 0 also in the result vector. And this function is going to return us this result vector when all the work is done. When it is going to return the result vector, that output of the vector is going to be assigned to this vector that we are having with the same name. We could change the name. We could call it x, for example, okay? And in order to show the elements of this result vector, which is storing actually the output of the function, we are going to have a for loop, the iterating variable called num. It is going to iterate over the elements of the result vector, and in each iteration it is going to print it. So when I run, we expect to see 2, 1, and 0, exactly as we expected, 2, 1, and 0. So these are the elements that we are looking for. So in this program, we learned how to find elements in a vector that are smaller than their left and right neighbors. Thank you for watching. Hello everyone, welcome back. In today's video, we would like to write a program to create an n multiplied by n matrix by taking an integer n as the input from the user using vectors. But before that, let me review some concepts of vectors for you. So the first thing is when we want to initialize a one-dimensional vector with size n, we're going to initialize it like this. So this line is going to create a one-dimensional vector with size n of integer type, okay? Where all elements are default initialized. For example, when we are having the integer type, all the elements are 0, okay? So this line represents a single row of matrix. However, if we want to have two-dimensional vectors, we need to have vectors of integer with size n, where each inner vector is a vector of integers of size n. So this is how we're going to read it. So with this line, we are creating a two-dimensional vector with size n. Okay, and each row is initialized as a copy of vector of integers with size n. Okay, so this is basically how we can declare. We learned it before, how to declare a two-dimensional vector of integer with size n. Okay, where each inner vector is a vector of integers of size n. So we are going to have, for example, row 1 and row 2. Okay, so the size of the row 2 equals to the size of row 1, for example. Okay, this is how we're going to have a two-dimensional vector, where one-dimensional vector is only having one row and row 1, and it is going to have only two elements, for example, in this case. But for two-dimensional vectors, we are having multiple rows, maybe 2 rows, maybe 5 rows. Okay, and each inner vector, so this one is an inner vector, for example, is a vector of integer of size n, and size n is the size for the outer vector. Okay, so this is a review of vectors of two-dimensional and one-dimensional vectors. So what we want to do is to ask the user to enter one number, for example 5, and then create a matrix using vectors, or let's say create a two-dimensional vector that is having the size of 5 by 5. Okay, and then ask the user all the elements. After that, we are going to show it in the output. So let me run the code once to see how it works. So it says enter the size of matrix. So I would say 3, for example. So I would like to have 3 multiplied 3 by 3 matrix. So I say 3. It says enter the elements row by row. So we are going to start from the first row, then the second row, and then the third row. And in each row, we are having 3 columns because it's a 3 by 3 matrix. So I would like to say 1, 2, 3, 4, 5, 6, 7, 8, and 9. And then we are displaying this matrix. So 3 by 3 matrix. This is how we are going to execute the program. This is how it works actually. It is going to ask me the n from the in the terminal from the user or me, and then we are going to enter the elements. So 3 by 3 matrix is going to have 9 elements. So I'm entering the 9 elements. I want my elements to be from 1 to 9, and it is going to store it row by row. So 1, 2, 3, 4, 5, 6, and 7, 8, 9. 3 rows and 3 columns. So this is how the program works. So we would like to write that program. To do that, first of all, we are declaring one integer n. We are showing this message to the user, enter the size of the matrix. Then we are storing it. Then I'm having my matrix or my two-dimensional vector called matrix. Let's say it's a vector of integer type with size n, and each inner vector is a vector of integer type with size n. Okay. Then we are going to have a nested loop to ask the user to enter the elements. So first we are going to have the I, which is the outer loop, and then this one, which is the inner loop, and this one is for row, and this one is for columns. Okay, then whatever the user is going to enter, it is going to store it using the syntax in the matrix vector I and j. For example, in the first iteration, we are going to have I equals to 0, then j equals to 0, 1, and 2. Then we are going to have I equals 1, j equals to 0, again 0, 1, and 2. And finally, we are going to have I equals to 2, j equals to 0, 1, and 2. And we're going to store based on the user input. So first of all, when the user is going to enter the first number, it is going to be stored in the I equals to 1, j equals 0 means, for example, if I'm having this part, and then let me write down an example, it would be easier. So for example, here if I say I equals, in the first iteration, I equals 0, j equals 0, we are going to store in the row 0, column 0. Okay, so row 0, column 0 is this one, and I would like to type down number 5, for example. Okay, then in the next iteration, I still remains to be 0 because it's a nested loop, and we are going to increase the value of j firstly. So j from 0 is 1, so we are going to have I equals 0 and j equals 1. Therefore, we are going to have the element of the first row because I equals 0 and the second column. And then we are going to type down, for example, 10 here. Then we are going to have I equals 0, j equals 2. Therefore, we are going to type down in the first element and third column. And therefore, I'm typing down, for example, number 15 to be there. Okay. Then when all the iteration for j is finished, we are going to now increase the value of I from 0 to 1. And then we are going to enter the j one more time. So I equals 1, when j equals 0, when j equals 1, when j equals 2. So we are going to fill the second row for column 1, column 2, and column 3. So I type down, for example, 20, 25, and 30. Okay, and then when all the iteration for j is finished, we are going to increase the value of I one more time, and I equals 2. And 2 is lower than n, which is 3. Yes, so we assume that the user is going to enter n equals to 3. It's just an example. So I equals 2 and j equals 0, 1, and 2. So the third row and 1, 2, 3 columns are filled. For example, 35, 40, and 45. So let me run the code up until here so we see. I say I want a matrix 3 by 3. I'm going to type down 5, 10, 15, 20, 25, 30, 35, 40, 45. And we are displaying this matrix exactly as we expected here and as we analyze through the nested loop. Okay, 5, 10, 15, 20, 25, 30, 35, 40, and 45 is the output. Okay. But after storing all the elements in the two-dimensional vector, we need to show it in the output as well. So I'm showing this message saying that the 3 by 3 matrix is, and then we are having a nested loop. Again, I from 0 until it is lower than n, and it is going to loop through rows, and here it is going to loop through columns, j for us, starting from 0 until j is lower than n, and then we are going to print and show this matrix element in the output. For example, when I equals 0, j equals 0, 1, and 2, so it is going to print for us 5, 10, and 15. Okay, so the first row, which is I equals 0, and then 3 columns. First column, second column, and third column, which is 5, 10, and 15. Then I has increased to from 0 to 1, so we are going to fill the second row and first column, second column, third column with different values of j when we are doing the iteration. So 20, 25, and 30. Okay, and finally when I equals 2, we are going to have 35, 40, and 45. So this is how this program works. We are printing out in the output, let me say, 10, 15, 20, 25. This time I started from 10 and not 5. 30, 35, 40, 45, and 50. Okay, so this is the matrix 3 by 3, and we are having the output of the matrix here. So we learned how to declare a two-dimensional vector with size n. We read n from the user. We had a nested loop to get all the elements one by one of these two-dimensional vector called matrix from the user, and then how to display it in the output. Thank you for watching. Hello everyone, welcome back. In today's video, we would like to write a program to capitalize the first character of each element of a given string vector and return the vector. So here in the int main function, we are having a vector of a string called words, and it has these 4 elements that are a string. This is why we have a vector of a string, okay? These 4 strings here, I would like to have them in this way. So the first letter of each of them, I would like to be capitalized. And in order to do that, we need to define a function. Here is my function. So first of all, we are declaring and initializing a vector of a string called words. Then I'm having a function called capitalize first letter. And I'm passing one argument called words to this function. And the output is assigned to words vector. So we are having a vector being initialized and declared here, and it is going to be modified by the output of this function. So when I have the call of this function, let me go up and see what's happening in the function. So this is the name of the function. The output of the function is a vector of a string. So the output of this function is a vector of a string, and this is why the output is assigned to words vector, which is also a vector of a string. And this function capitalize first letter, it's the name of the function, and the argument is words. Then the name of the word it comes from this part. We can name it whatever we want, but the type of this variable should be a vector of a string, and we are using a call by reference because we want to modify this vector, because we want to capitalize the first letter of each string inside this vector of a string. And in order to capitalize the first letters, we need to loop through this vector. So we start our iterating variable from 0 to be continuous as long as this iterating variable I is lower than the size of my vector. And in each iteration, after each iteration, we are going to increase the value of I by 1 unit. And in each iteration, we are having the words I and 0. So words, we are typing down the name of the vector, okay? So this is the vector. And when we say words 0, it means that we are talking about the first element of the vector. Let me type them down here so I can explain it better with the example for you, okay? So this vector, each element has its own index. Okay, this is the index 0, this is the index 1, this is the index 2, and this is the index 3. Okay, so when I equals 0, we are talking about the index 0 element of the words vector. So index 0 element means the index 1, which is hello, and then I'm typing down 0 here. Okay, so it means the first letter of the first element of the vector called words. So the first letter of the first string or first element of the words vector, which is this one. So this is the first letter of the first element of the words vector. And then it is assigned to two upper functions. So two upper function, in order to use that, we need to include this header. This is something to consider. And then we use the two upper functions. So two upper function is going to capitalize the letter that we are mentioning. And in the parentheses, we are saying that in the first iteration, capitalize the first letter of the first element of the words vector. Okay, and when it is done, assign it to the first element, to the first letter of the first element of the word vector. So in the second iteration, when I equals 1, we are going to have two upper words 1 and 0. So this two upper function is going to capitalize the first letter of the second element of vector words. So the first letter of the second element of vector words, it is going to be capitalized using the to upper, and it is going to be assigned to the first letter of the second element. It means that, so it was word previously, and after this modification it becomes word, because we are capitalizing this letter and we are capitalizing it, so it is now a capitalized W, and that is assigned to the first letter of the second element of the words vector. Therefore it becomes like this. Okay, then capitalize the first letter of the third element using the two upper function. So this is what we need to have here, for example. Oops, let me close the parentheses here as well. Okay, so this function to upper is going to now capitalize the first letter of the third element of the word vector. So the first letter of the third element, this is the third element, 1, 2, 3. Okay, this is 3 with index 2, which is the index 2. Okay, of words vector. So we are capitalizing this C, so we are doing this CPP now, and this is going to put instead of CPP. Okay, actually only the C part is going to be modified. So this C is going to be to put instead of this small letter C. Okay, and then finally in the last iteration we are going to have this part to upper words 3 0. So we are going to modify the first letter of the fourth element, which is the programming of the word vector, using the to upper function. So we are going to have P to put instead of P. Okay, and it is assigned to the first letter and the fourth element of the word. So this function is going to first capitalize the first letter of this fourth element of the word function of the word vector and assign it actually to the current first letter of the fourth element, which is this one. Okay, so here also we are going to have W to put instead of W. And then here we are having H to put instead of H. Okay. After doing these modifications, after this for loop is finished, we are going to return these words. Okay, so we modified the vector and we are returning it. So the return of the function is a vector of a string, which is true, so we are returning it. Then the output of the function, which is a vector of a string, is assigned to words, which is also a vector of a string. Okay. Then we are having a for loop to now print the modified vector. So the printing the modified vector would be like writing a for loop starting from 0 until I is lower than the size of the vector. And then in each iteration, we are going to show the element of the word vector. So we are going to first have the first element, then word second element, then third element, and then the fourth element in the output. Okay, so when I run the code, here is my original vector. Okay, all of them are small letter, so they are lowercase. Here we see hello is starting with a capitalized H, the same with the second element, third element, and fourth element. Okay, so this is how we can actually have a function to uppercase the first letter of each element of a vector of a string, and then this is how we can print a vector of a string in the output. Thank you for watching. Hello everyone, welcome back. In today's video, we would like to write a program to separate odd and even integers into separate vectors. Okay, so here I'm having my main function. Here is the main function. I'm having one variable called n, it's of integer type. I'm having three vectors of integers that are called nums, odds, and evens. First of all, I'm going to ask the user enter the number of integers. So for example, the user wants to have a vector with 10 elements. Okay, therefore n equals 10. N equals 10. And then we are going to tell the user enter the integers. So we are looping from 0 until I is lower than 10. So from 0 to 9, we are going to have 10 elements. And whatever the user is going to enter, we are going to store it in the num variable. And we use the pushback function to assign that num into the nums vector of integers. So this is how we are creating the first vector. Okay, so the first vector is being created, and for example, the user is going to enter 10 elements: 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So these are the elements of the vector called nums. Okay, and then we would like to separate even numbers of this vector and assign it to a vector called evens, and then separate the odd numbers in this vector and assign it to a vector called odds. So we are going to ask the user how many elements you're going to enter, then create a vector with that element, then separate the odd elements of that original vector that was created by the user, and push back the elements into the vector called evens, and also separate the odd numbers and push back them into the odd vector. So let me run the code once. When I run the code, it says enter the number of integers. I would say 10. So it says enter the integers 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So it says the odd numbers are 1, 3, 5, 7, 9, and even numbers are 2, 4, 6, 8, and 10. So these are two created arrays from the original arrays that we created here. And this one is having the odd numbers, and this one is having only the even numbers. So we're going to create the original vector here by asking the user to enter the integers. Then we are going to call this function separate odd even, and we are passing three arguments: the original vector, the odds vector, and the evens vector. Okay, so when compiler sees this call of the function, it goes and starts to implement this part. Okay, so this is a function called separate odd even. It's a void type, so it's not going to return anything, and it has three arguments separated by commas. And in the arguments, we are having the vectors of integers, as you see for all of the arguments, vectors of integers, and we are having a call by reference. So we are going to work with the original vectors and not a copy of them. And because we don't want to change the original vector, which is called nums, as the first argument, this is the first argument of the function. So the first argument is the original vector that we are creating from the user. That one we are using the const keyword, so we don't want to modify that, and we're going to make sure that we are not modifying it accidentally. But for the rest of the arguments, the second and the third arguments, we are not going to have the const keyword because we indeed would like to modify them, because these vectors are now not having the odds and evens values, and we would like to push back some values into them. In order to push back values and add some numbers into these two vectors, we are going to loop through the first and original vector. And how do we know that a number is odd or even? So a number is even if it is divided by 2 and the remainder of this division equals 0. Okay, otherwise it is an odd number. So this is how we can identify even numbers and odd numbers. So if a number is divided by 2 and the remainder of this division equals 0, it means that number is even. Otherwise, it's an odd number. So we are iterating through all the elements of the original vector called nums. We are having for each variable num in the nums vector, if num divided by 2 and the remainder of this division equals 0, push back that num into the evens vector. Otherwise, push back that num into the odds vector. So for example, it is going to, in the first iteration, it is going to divide 1 by 2 and the remainder of this division equals to 0. This is the first condition. Is this statement true? No, this is false. Because this statement is not true, it is going to jump into the else and add this 1, which is the first value for the iterating variable, is going to push back 1 into the odds vector. And then in the second iteration, for example, it is going to divide 2 by 2 and the remainder of this division equals 0. Yes, so this is true. Therefore, this statement is true. So 2 is divided by 2. The remainder of this division equals 0. Yes, so that number 2 is going to be pushed back to the evens vector. So this is how we are going to create we are going to fill evens and odds vector. And now these two vectors are modified because we are having a call by reference and we are not using the constant keyword for these two vectors. Therefore, we are allowed to make modifications. So we modified them because we are using the call by reference. We could modify the original vectors. And after this call, these two vectors are also filled. Now we are going to show the odd vector. We are going to have this message odd numbers in the output. Then we are having a for loop. We are creating an iterating variable called odd. And for each odd in the odds vector, we are going to print the odd element. So this one could be x for the sake of simplicity, for example, and this one could be y, for example. For each y in the odds vector, print x for me. And the odds vector, we created it was 1, 3, 5, 7, and 9. And also, and so this for loop is going to print x in each element in each iteration. So 1, 3, 5, 7, and 9, these are the elements of the odds vector. So x is going to print in each iteration these numbers. And also here we are having a for loop over the evens vector, and for each y that is iterating through the evens vector, it is going to print y in each iteration. So it is going to print us 2, 4, 6, 8 for us, and 10 finally. Okay, so when I run the code one more time, we say we are going to have an original vector of 10 elements, and these 10 elements are 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And it says, okay, the odd numbers in the original vector are shown in the odd vector, and these are 1, 3, 5, 7, 9, and the even ones are 2, 4, 6, 8, 10, as we expected here. So in order to review what happened, we created an original vector of the user input. Then we called this separate odd even function and passed 3 arguments. Here we are looping over the original vector, and if each element of this original vector divided by 2 and the remainder of this division equals 0, we are going to push back that element into the evens vector, because when a number is divided by 2 and the remainder of this division equals 0, it means that it's an even number. So we are going to push back that number into evens vector. Otherwise, it means that it's an odd number. So we are going to push back that in the odds vector, because when for example 7 is divided by 2, the remainder of this division is not equal to 0. Therefore this statement is not true. Therefore we are going to jump into this else part and, for example, push back 7 into the odds vector. After filling these two vectors, evens and odds, after this call, we are going to print the odd vector by iterating through it, and we are going to print the evens vector by iterating through it. Thank you for watching. Hello everyone, welcome back. In today's video, we would like to write a program to find the maximum and minimum elements in an array. So here is how we would like to proceed. We would like to ask the user to enter the number of elements in the array. Then we are going to get that number and we are going to create an array using dynamic allocated memory. Then we are going to ask the user to give us the elements that they want to have in their array. Okay, so then we are going to fill the array, and the array is created and initialized and it has some elements now. Then we are going to find the minimum and maximum elements of this array by going through all the elements of this array using a for loop. So here is my integer n being declared. We are going to ask the user enter the number of elements in the array, and we are going to store it in the variable n. Then we are just checking to see if n is lower than or equal to 0, saying that invalid size of the array. So, and then return 1 to exit if the input size is invalid. And if n is larger than 0, we are going to create an array. So we are going to have a dynamically allocated memory for declaring an array with size n, and this n was taken from the user. Then we are going to show this message. So enter, for example, n elements that you would like to have in your array. We are going to have a for loop starting from 0 until n, and in each iteration we are going to store whatever the user is going to enter as the ith element of array. So for example, if n equals 5, we are going to have 5 elements in our array starting from 0 till 4. Okay, so these are the numbers that our iterating variable I is going to take from 0 to 4. Then, for example, when I equals 0, we are going to enter the first element of the array, and it is going to be stored as the first element of the array using the cin. Okay, so in the first iteration, whatever that we enter, it is going to be stored in the first element of the array, which we know that the first element of the array has the index 0. When I equals 1, we are going to enter, for example, the second element of the array, and we are using the cin syntax to store it as the, for example, ith element of the array called arr here. Okay, until the end. After this has been done and all the elements from the user has been read, we're going to have two variables. So two variables are called max element and min element. They are of integer types, and we are initializing them to be the first element of this array. This is just an assumption. Okay, just imagine that I would like to have an array with size 5, and the elements of the array are 1, 2, 3, 4, and 5. Okay, and then I am having this assumption that max element equals 1 and min element equals 1 as well. This is just an assumption for the beginning, and we're going to change it later on. Okay, after having this initialization, we are going to iterate through the array. To do that, I'm having my iterating variable I starting from 1. It is going to continue as long as I is lower than n, and we're going to start from 1 because, and not from 0, because the index 0 is for the first element, and first elements are already assigned to min and max, and we are going to, in each iteration, we are going to compare the current element with min and max element. Therefore, we don't need to start from 0, although we could do it, but there is no need because already we know they are assigned to these two elements. Okay, so in the first iteration, I equals 1. Okay, I equals 1. When I equals 1, we are here comparing if, let me type it down, if the second element of the array is larger than max element. And it means that the second element of the array, we assume that this is my array. So the second element is number 2. So number 2 is larger than number 1 because the max element, we initialize it to the first element and the first element is 1, therefore max element is 1. So if 2 is larger than 1, meaning that the second element of the array is larger than the max element which was initialized with the first element, then if this is true, which is true in this case, assign that element to max element. So max element equals 2 now. Okay, and then assign that element to max element. So if, for example, when I equals 1, if the index 1 element, which is the second element of this array, is larger than max element, which is 2 larger than 1, if this statement is true, enter this if condition and assign that element, which is 2, to be new max element. So this is my updated max element. Okay, and then again here, when I equals 1, we are saying that if the second element of the array is lower than min element, we're going to check. It means that the second element is 2. Is it lower than the first element? No, it's not lower than the first element. So this statement in the first iteration when I equals 1 is not true. Therefore, we are not going to enter this if condition. So we go up and now I equals 2. Okay, so let me type down I equals 1 here, not here. We go up and I now equals 2. I equals 2. When I equals 2, we are going to have this if condition to check. We say that the third element of the array is larger than max element. Okay, it means that the third element of the array is number 3. Okay, so number 3, we are checking to see if number 3 is larger than max element, and max element was number 2. Okay, and this statement is true. Is it true? Yes. So the third element is larger than the the max element, sorry. Therefore, that element is going to be assigned to max element. Therefore, max element is going to be equal to 3 now. Then we are going to have it here. Okay, now I equals 2. We are going to have the third element of the array lower than min element. Okay, element. In this case, we are going to have the third element, like number 3, to be lower than 1. Is it true? No, it's not true. Therefore, this statement is not true, and therefore we are not going to enter this if condition. Okay, if it was true, for example, just imagine instead of 3 lower than 1, we had something like 3 lower than, for example, 5, for example. Just imagine. If this was true, then it meant that this was true, and then 3 would have been assigned to be the min element. Okay, but this is not the case in our example here. Then we are going to go up again, and we are going to have I equals 3. When I equals 3, we are going to have the fourth element of the array to be larger than max element, and we are going to have number 4 to be larger than 3 because the fourth element with index 3 is this element, and then the max element is number 3 here. So we say the fourth element larger than max element, so 4 larger than 3. Is it true? Yes, this is true. Therefore, we are having max element equal to 4. So because that ith element is assigned to max element. Okay. Then here again, we are going to say I equals 3. So 4 is lower than 1. Is it true? No, it's not true. Therefore, this condition is not true, and we are not going to enter this if condition. We are going to go back up again. We are having I equals to 4. So this is the last iteration, and we are having the fifth element of the array larger than max element. We are checking this if condition in here, okay? And we are typing it in here in the iteration when I equals 4. And this basically means to check if 5 is larger than 4. Is it true? Yes. When it is true, when this condition is true, we are going to enter this if condition, and here we are going to assign that number, which is 5, to be the max element, which is already 4. So max element equals 5. Then we are going to finish this if condition and enter this if condition to see if this condition is true or not. So here I equals 4, and we are saying that number 5 is lower than 5. Is it true? No, it's not true. Therefore, this part is not true, and we are not going to enter this part. And I equals 4 is the largest number that it could get because n equals 5, and I is going to continue as long as it is lower than 5. So 4 is lower than 5, and we cannot increment the value of I anymore. Therefore, this if condition is finished. And finally, we are going to show max element and min element parameter to the user. So when I run this code, it says enter the number of elements in the array. I would say 5. It says enter 5 elements. So 1, 2, 3, 4, 5. And it says maximum element 5, minimum element 1. Based on what we explained, we are going to have this computation in the output. Thank you for watching. Hello everyone, welcome back. In today's video, we would like to write a program to merge two arrays of the same size, and we are going to sort the merged array. So we're going to ask the user to give us the number of elements that the user wants to have for both arrays because they are of the same size. Then we are going to declare the arrays dynamically using dynamic allocation of memory. Then we are going to ask the user using for loops to give us the elements in each array. Then we are going to merge these two arrays and create the third array. After that, we are going to sort the third array, and then we are going to display the third array. So in order to do that, let me first run the code and show you how the code works. It says enter the size of the array. So I would say I would like to have two arrays of size 2. It says enter the elements of the first array. I would say 1 and 2. Enter the elements of the second array, 3 and 4. And it says merged array is 1, 2, 3, and 4. So this is how the program works, and we would like to have the code for this program. We are initializing one variable called n, and then we are asking the user to enter the size of the arrays. Whatever the user is going to enter is going to store it in n. Then we are dynamically allocate memory for our arrays. So this is the first array with size n, second array with size n, and the third array which is of the merged array, and it is going to have double of the size n. Why? Because the elements of this one and this one is going to be inserted in this one, so it needs to have the size double n, which is the individual size. For example, first array has 2 elements, second array has 2 elements. Therefore, merged array will have 4 elements, okay? And if the user enters, for example, number 2 to be the size of the array, so we are going to have the first array with 2 elements, second array with 2 elements, and therefore we are going to have the merged array with 4 elements. So it is the double of the n that is entered by the user. This is the size of the merged array. Then we are going to have a for loop starting from 0 until I is lower than n, and we are typing down the name of the first array, and in each iteration we are going to insert the numbers of the user to the array of the first to the elements of the first array. And then we are going to have another for loop here to insert the user input for the second element, for the elements of the second array. For example, here the user enters, they would like to have n equal to 2, for example, n equal to 2. Therefore, I will get values 0 and 1. So 2 iterations we are going to have. When I equals 0, the R1 element 0, and then we are going to have another iteration when I equals 1, and we're going to have this here. So in the first iteration, the user is going to enter the first element of the first array, and in the second iteration, the user is going to enter the second element of the first array, and we are going to have the elements of the array of the first array being inserted like this in this for loop. We are storing the elements, and then with the same logic, because we assume that the user enters, for example, number 2, when I equals 0, we are going to have R2 0, so the first element of the second array inserted, and then the second element of the second array is also inserted and stored in the second array. Okay, now we would like to merge these two arrays. In order to do that, we need to have a for loop, again, starting from 0 until n. But before that, let us assume that the user is going to enter 1 and 2 for the first array. And this is just an example to make it clear. So, and the second array has two elements that are 3 and 4. Okay. So here we are going to create the merged array. So we're going to insert some elements into the merged array, and it is going to be elements of the first and second arrays. Okay. So here we are going to start from 0, and we're going to continue as long as n is lower, I is lower than n. So I is going to take value 0 and 1 for each iteration. So we are going to have 2 iterations. Okay. And in the first iteration, when I equals 0, we are assigning merged array 0 to be equal to the first element of the first array. So we are saying to, we are basically, what we are doing here is the following. We are assigning the first element of the first array, which is number 1, to be inserted as the first element of this merged array. Okay, so we are creating the merged array to be now have the number 1 as its first element, for example. So in the first iteration, when I equals 0, this line does this. It is assigning the first element of the first array to be the first element of the merged array. And therefore, we are having the first element of the merged array to be like that. Okay. Then for the same first iteration, we are having this as well. So we are typing down merged array. N was number 2. So 2 plus I, which is 0 in this iteration, we are going to have number 2 to be equal to the first element of the second array. Okay. So here our merged array has the size of 4. It means that it will accept 4 elements, 1, 2, 3, and 4. Okay. So this is the first element for the moment. Here I'm saying that the merged array element n plus I, and I in the first iteration equals to 0, and n equals 2 because we assume that the user is going to enter the size of the arrays to be 2. Here we wrote it. Yes, here it is. Then we are assigning the first element of the second array to be the third element of the merged array, which is here. Okay. So I would say this one more time. we are assigning in the first iteration when I equals 0. We know that n equals 2 in this example. We just assumed it, okay? The first element of the second array to be inserted as the third element of the merged array. And how we got this third element? So this third element is after the first array is inserted. So the second array is going to start as of third element. How do we know that? Because n equals 2. When n equals 2, we know that if we insert the first array into this merged array, we are going to have two space being filled. Therefore, as of the first space is going to be empty. Therefore, the starting point of insertion of the second array for its first element is going to be n plus I. And in the first iteration, I equals 0, therefore it will be n the starting point of the insertion of the second array. Okay, so the first element of the second array is inserted as the third element of the merged array. Okay, then we are going to go up and we are going to increase the value of I by 1 unit. So I now equals 1. When I equals 1, we are going to have merged array 1 equals R1 R1. So it means that to assign the second element of the first array, which is number 2, to be assigned to the second element of the merged array. So it was empty and now we're going to enter 2. Okay? So in the second iteration, when I equals 1, we are going to assign the second element of the first array, this number 2, to the second element of the merged array. So this is the second element of the merged array. So number 2 is there. And then for this line, when I equals 1, we are going to have the following. Merged array, then in parentheses, we are having n plus I. Okay? So we know n equals 2 and I is now 1 because now we are in the second iteration. It equals array 2 element index 1. Okay, so we are going to assign the second element of the array 2 to be equal to the fourth element of the merged array. This is the 2 plus 1 will be 3, and this is the index 3 is the fourth element. Okay, this is the fourth element. So this is how we merged these two arrays. We iterated over the iterating variable from 0 until I is lower than the size of the array. Then in each iteration, when I equals 0 and 1, we are going to fill the first two elements because n equals 2 for the assignment of the first array to the merged array, and then we are going to use the last two elements for the insertion of the second array into the merged array. Okay, now the merged array is created and has 1, 2, 3, 4. So these are the numbers. But this is just an example. For example, if you solve this program, you may, for example, have so this was my example. The array 1 was having number 1 and 2, and array 2 was having number 3 and 4. If you solve it, for example, you can add 10 and 5. Then for the second array, you might have these numbers of, for example, 2 and 37, for example. So you may solve it using these elements. Okay, you may want to have these numbers for your first array and then these numbers for your second array. Then your merged array with this logic will be 10, 5, 2, and 37. Okay, next step is sorting the array. So when I was having this example for myself, so the first array is this, and this is the second array, and this is the merged array, and merged array is already sorted. Okay, and we are going to sort it anyway, but it is already sorted. You could have your first array 10 and 5. These are the two elements of your first array, and the second array to be having 2 and 37. These are the two elements. And then your merged array would have look like something like this: 10, 5, 2, and 37. So you're going to sort this array as well. Okay, we're going to sort it anyway, but this one was already sorted. Then we are going to use the sort function. We are going to type down merged array and separate it with the comma, and then merged array plus 2 multiplied by n. And this merged array, so when we are using the sort function, we are going to show the starting point and ending point. Okay, so the starting point is the merged array. So it is going to consider index 0 of the merged array when we type it down, merged array. Okay, and it is going to continue from the index 0 until double of the size, double of its size. Assuming that, for example, we are having an array of size 4, we are having these elements. Merged array is the starting point, meaning that we are going to start from index 0. So this is the index 0, and we are going to continue. Let me type it down. So it will be something like this: sort from index 0 until 0 plus 2 multiplied by n. So 2 multiplied by n, it means 2 multiplied by by the size that was entered by the user. So n was the user input, so 2 was what the user entered. And then we are having 2 times 2, we are having 4, and 4 plus 0, it is 4. So we are going to perform the sorting for the merged array from index 1 inclusive until index 4 exclusive. So ending point is exclusive. Okay, this means that it is going to have, so this is the index 0, 1, 2, and 3. It is going to have the sorting of the merged array from 0 inclusive until the ending point, which is exclusive, until index 4, and we don't have the index 4. So when index 4 is exclusive, we are going to have the index 3 inclusive as the ending point. So this means that the merged array is going to be sorted from the start until the end. Okay, then the work is done almost. We are going to show this message saying that merged array, and then we are going to iterate through 0 until I is lower than 2 multiplied by n, or we could simply type down 4, for example, because n equals 2, and 2 multiplied by 2 means that we are going to continue as long as I I is lower than 4. And basically we are typing it down because this is the size of our array, merged array. We could say merged array dot size in empty parentheses. And in each iteration we are going to print each element of the sorted array. So when I equals 0, we are going to print, for example, 1. Then I equals 1, we are going to print 2, and then 3, and then 4. And we are having the new line at the end. We are having the endl for a new line, and we are going to deallocate dynamically allocated memory for these 3 arrays. So when I run this code one more time, we're having enter the size of the array. I would say, for example, this time 3. It says enter elements. I would say 10, 5, and 8, for example. Enter elements of the second array. I would say 8, 2, and 1. And it says merged array, which is sorted also. It's 1, 2, 5, 8, 8, and 10. So this is how we can merge 2 arrays and create a new array using dynamically allocated memory and using for loops to assign the elements of the merged array, and use the sort function to sort the merged array, and finally to show the elements of the merged array. Thank you for watching. Hello everyone, welcome back. In today's video, we would like to write a program to count the number of duplicates. Here is our array being declared and initialized. We are having an array with size 4, and we are having 1, 2, 3, and 4 elements. and the second element and the third element are repetitive. So we are having the duplicates. So we would like to write a program to count the number of duplicates. In this example, we see that we have one duplicate. Okay. Then we are having the variable n, and the variable n is going to calculate the size of array. And in order to count the duplicate, we are having this variable duplicate count equals to 0, and we are initializing it to 0. Then we are going to have a nested loop. We need a nested loop. For example, here I type down our array one more time. It's 1, 2, 2, and 3. Okay. In order to understand if we have duplicates in this array or not, we need a nested loop. So the outer loop and the inner loop. So the outer loop, for example, I is the iterating variable for the outer loop. We're going to have the I equals to 0, then j equals to 2, 2, and 3. And we are going to compare each element with any other element. So we are going to compare if this element equals to this element or this element or this element. This way we are going to compare the first element with the second, third, and fourth element to see if we have any duplicates or not. Then we are going to compare this element, and I equals, for example, 1 because the index of the second element is 1. We are going to compare this element with this element, this element, and this element. So of course, we are not going to compare the second element with the second element because they are similar for sure, and we don't want to count that. So any similarities that are not having the same index must be tracked. So this one and this one, they are having the same index because they are the same element. So this is the second element and the second element is here. So the second element should not be compared with the second element, but it should be compared with the first, third, and fourth element. Also, for the third element, it should be compared with the first, second, and fourth element. So using a nested loop, we are going to compare each element with any other element to see if we have duplicates or not. So here is my outer loop. We are having the I iterating variable equals to 0 as long as I is lower than n. We are going to enter this loop, and we are going to have the count variable equals to 0. Okay, this count equals 0, and then we are having the inner loop j here. So inner loop. Okay, and here when I equals 0, j equals 0, 1, and 2, and 3. When I equals, for example, 1, j again equals 0, 1, 2, and 3. And it is going to continue as long as I equals 3. Still, j is going to be equal to 0, 1, 2, and 3. So in the first iteration, I equals 0 and j equals 0. So the outer loop, the I equals 0, and the inner loop, j equals 0. When we are in the inner loop, we are going to check this if condition. We are going to check if I is not equal to j, because as we mentioned, we don't want to compare the first element and the first element, okay? Because it makes no sense. Definitely they are similar. So this condition helps us to avoid comparing the first element with the first element. Okay, we want to compare first element only with any other elements. So we type down if I is not equal to j and ith element of the array equals the jth element of the array. So I equals 0 and j equals 0, it is not passing this condition. And because we are having AND operator, both conditions must be true. Because this one is not true, therefore we are not going to enter this if condition. We go up back again and we increment the value of j. So j now is equals to 1, I remains 0. We are again checking if I is not equal to j. So I equals 0, j equals 1. They are not the same. So this is true. And the ith element of array equals the jth element. So the element of the index 1 of the array is 2, and the element with index 0 of the array is 1. And they are not similar. 1 does not equal 2. Therefore, this part this time is not true, so we are not going to enter this if condition. We are going to go back up again. We're going to increase the value to j. I remains 0. 0 equals to 2. No, therefore this part is true. And we are saying that the ith element of the array equals the jth element. Then the jth element with index 2 is this element. So 2 equals to 1. No, therefore this if condition is not true. And we are not going to enter this if condition. We go back up again and increase the value of j to 3. So now we are having I equals to 0 and j equals to 3. I is not equal to j. Is it true? Yes, because 0 and 3, they're not equal. And the ith element of array equals the jth element of array. So the ith element is this one and jth element is this one, and they're not equal. Therefore, this condition again is not true, and we're not going to enter this. And this inner loop is finished because j got the maximum value. So this loop is also finished, and we are going to check if count is larger than 0. We initialized count to be 0, and then if we were going inside this if condition, we were going to increment the value of count. But we couldn't go inside this if condition because we didn't pass the conditions of this if. Therefore, we didn't change the value of count, and count equals to 0. So if count is larger than 0, it's not larger than 0, it is still equals to 0. Therefore, we are not going to enter this condition, and this if is not executed. We go up. This time, we are going to increment the value of I. So I has changed from 0 to 1. Okay, so now I is having this value. Okay, so I equals to 1 means that it is getting the element with index 1, and index 1 is the element 2. The second element, which equals 2, is the is equals to I. So I is talking about this element in this iteration, and j is going to take values from 0 to 3. So j is going to take any of these values. So I equals 1, j equals 0. So I is talking about this element and j is talking about this element. Are they similar? No. So this condition is true. And the ith element equals the jth element. So this is 2, this is 1, and they are not similar. Therefore, this condition is not true. We are not going to enter the if. We're going to go back up. We're going to increase the value of j. J equals to 1 now. I equals to 1. They are equal, and here we are checking if they're not equal. So this condition is not true. We're not going to enter if. We're going to go up, increase the value of j. J equals 2. I equals 1. They're not equal. Yes, because the index I is 1 and j is 2. Therefore, they are not similar. So this condition is passed, and we are going to compare the ith element with the jth element. So the third element is this one, and I is talking about the second element, which is this one, and they are equal. Okay, so we also pass the second condition. Therefore, we are going to enter this if condition and increment the value of count by 1. So now count equals 1. And we found a duplicate because we see that we have the second element to be 2 and the third element to be 2 as well. So we found a duplicate. We are going to increase the value of count. Then this if condition is finished. J is going to take the value 3. I equals 1. When I equals 1, we check I is not equal to j. Yes, 1 is not equal to 3. And the ith element equals the jth element. So I is number 2 and j is number 3. They're not equal. This condition is not true. We're not going to enter this part. And then this loop is finished because j took the value 3, which was its maximum. And then we are going to check if count is larger than 0. Yes, because we incremented the value of count and it is now larger than 0. So count equals to 1. And if count is larger than 0, we are going to enter this if condition and increase the value of duplicate count. Okay? We increase the value of duplicate count, which was initialized to 0. Okay? Then we are going to go back up again, and this time we are going to increase the value of I again. So now I equals 2, j equals 0, 1, 2, and 3. And when I equals 2, it is talking about this one, and j is going to take these values, all of them. So I equals 2, j equals 0. They are not similar. They are not the same. Yes, and are the elements of the array with ith element and jth element are the same? So this is 2 and this is 1. So they are not similar. This if condition is not passed. We increase the value of j. J equals to 1. So this part is passed again because I is 2, j is 1, and ith element and jth element. So we see that we are having 2 for the I and 2 for the j. So this is also equal because I is talking about this element and j is talking about this element, and I equals 2, j equals 1, and this condition is also passed, and this condition is also passed. So we enter the loop and we increase the value of count one more time, because anytime that we increase the value of I, we are initializing count to be 0 again. Okay, so when we increase the value from 1 to 2, we initialized count to be 0 again. Now count is 1 again, but this is the duplicate we already counted, yes? So because we already counted this duplicate. Now I is talking about this variable and j is talking about this variable, and in the previous iteration we counted this duplication, and we are going to find a solution for this later on this video. We increment the value of count, okay, and this if condition is finished, we go here and increase the value of j equals 2, I equals 2, they are the same, so this condition is not passed. Again, we increase the value of j, I equals 2, j equals 3. They are not the same because it is 2, this one is 3, so this condition is passed. Ith element equals the jth element, so this element equals to this element. No, not going to enter this part, and we finish this loop because j took the number 3. Then if count is larger than 0, increase the value of duplicate count. So duplicate count, in the previous iteration we assign it to be 1, duplicate count equals to 1. Now we are going to increase another 1 unit, the duplicate count, so it will be equal to 2. So now the duplicate count equals to 2. And we go back up again, we increase the value of I equals 3, and we assign count to be 0 again because we want to restart the counting. And j is going to take these 3 values. So 1, 2, 2, 3 are the values of j, and I is talking about the last element, and we're going to compare 3 with 1, 3 with 2, 3 with 2, and then we're not going to compare 3 with 3 because the indexing will be the same when I equals 3 and j equals 3. This condition is not passed, but because we don't see any similarities between 3 and any other elements, nothing is going to happen. We are not going to enter this loop as I explained earlier, and this loop is finished, and we check to see if we increase the value, incremented the value of count, and it is larger than 0. No, we didn't do that. And this for loop I is also finished because I got its maximum level. It must be it must be lower than n, and n is 4 because we calculate the size of the array, and the size of the array in this case is 4. Now you remember that we counted 2 and 2 in one iteration, and in another iteration I was pointing at the third element and it was equal to this element. Okay, so we found the duplicate, but we counted it twice. Because we counted it twice, we are going to have duplicate slash equal to, and this means that duplicate count equals to duplicate count divided by 2. Okay, so the duplicate count was equal to 2. We found it, and if it is divided by 2, it will be equal to 1, and 1 is assigned to this duplicate count. Okay, so this equation equals to this equation, but it's another way to type it down. Okay, therefore, the duplicate count was 2. 2 divided by 2 equals to 1, and 1 is assigned to duplicate count. Therefore, we are having only one duplicate. So because we counted it twice, we had this division by 2. And indeed, we are having one duplicate because we are having 1, 2, and 3, and this one is the duplicate. So we are having only one duplicate. And now that we know the duplicate, we are going to show this message in the output, total number of duplicate elements, and we are going to show this variable. So when I run this code one more time, we see that we are having the total number of duplicate elements equal to 1 as we expected in the detailed analysis of the code. Thank you for watching. Hello everyone, welcome back. In today's video, we would like to write a program to count unique elements of an array. So we are having a predefined array, and we see that this array has 4 elements, 1, 2, 2, and 3, and unique elements of this array are 1 and 3, because 2 has duplicate, so it's not a unique element. So we would like to write a program to print us this 1 and 3. We're going to calculate the size of the array using this formula, and we are assigning to variable n. Then we are having again a nested loop. So a nested loop would be working like this. So let me rewrite the array here. So this is our array. A nested loop will help us to have 2 iterating variables, one I and one j. Imagine I is iterating over this array and j iterating over the same array, okay? So when I is pointing at these elements, when I is getting the element equals to 1, and j gets these 4 elements. So we are going to compare 1 with 1, 1 with 2, 1 with 2, and 1 with 3. Then I is going to be incremented 2 with 1, 2 with 2, 2 with 2, and 2 with 3. And then 2 with 1, 2 with 2, 2 with 2, 2 with 3, and finally 3 with 1, 3 with 2, 3 with 2, 3 with 3, okay? And we see that here when we're comparing 1 with j, because this is I and these are j's. So when I gets this value, we see that we are comparing the first element with the first element as well. First element, second, and third, and fourth. So we allow to compare I equals to 0 and j equals to 0. It means that when the index of this array is 0 and we are talking about the first element with index 0, we can still have the talking about the index 0 or the first element of this array. It means that we are going to compare also the first element with the first element. In the previous example, we said that we don't want to do it because of that example. But here we are going to compare the first element with the first element as well. And if the first element with the first element equals, which is true, we are going to increment the value of count, okay? And then if and only if count equals to 1, it means that we are going to have unique elements. Because 1 equals to 1, it is true, we increment the value of count for this index. And when we compare this element with the second, third, and fourth, we see that they are not this one is not equal to any of them. It means that this element is unique, so there is no duplicate. But in the case of number 2, we are going to compare these two with the first element. They're not equal, so we are not going to increment the value of count. So this one equals to this one. They are similar, and we're going to increment the value of count, and now count equals to 1. Then we are going to compare this one with the third one, and we see that they are still similar. So it means that we are going to increment the value of count one more time, and count equals 2. And count, when it is more than 1, it means that we have duplicates. But if count equals to 1, it means that only the first element is being compared with the first element, with the corresponding element in j iterating variable. Okay, so let me illustrate it with an example. So when I run this code, it says that unique elements in the array are 1 and 3. So how do we do that? We have a predefined array, and we are calculating its size. We are having the outer loop I, then we are having the inner loop j, okay? We are initializing count to be 0. Then we are having the inner loop j. So I is going to take the value 0 and j equals to 0, 1, 2, and 3. Then I equals to 1, j equals to 0, 1, 2, 2 and 3. Then I equals to 2, j equals to 0, 1, 2, and 3. Let me have one space here. And then we are having I equals to 3, while j gets values of 0, 1, 2, and 3. So these are the iteration that we are going to have. So when the outer loop I equals to 0, j is going to take these values 0, 1, 2, and 3. So when I equals 0 and j equals 0, they are both talking about the first element, and we are saying the ith element of the array equals the jth element. Yes, so increase the value of count. This if is finished, and go up. Then I remains 0. We are going to have j equal to 1. 1 and 2, are they equal? No, increase the value of j. So 1 and 2 again is compared, the third element. Are they equal? No, we increase the value of j. So j equals 3, I equals 1, 1 equals 3 in this if condition. No. So we are not going to enter this if, and we are finishing this inner loop because j took its maximum level. And we are going to get out of this for loop, and now we are checking this one. If count equals 1. Yes, count equals 1 because we had 1 when I equals 0 and j equals 0. Okay, therefore print that element which is 1 for me in the output. And we go back up again, we increase the value of I, so I equals 1 now, and we are going to reinitialize count to be 0 because now we are going to iterate again. When I equals 1, j takes equal 0, 1, 2, and 3. So I is talking about this element and j is talking about these elements. So we say 2 equals to 1, no. So this if condition is not true. We increase the value of j. 2 equals 2, yes, this if condition is true. We are going to increment the value of count. So count equals to 1 now. Then we increase the value of j one more time. So we say I is showing this element number 2, and j is showing the third element with index 2. Okay, this one. Are they similar? Yes. So we are going to increase the value of count one more time. So count equals 2. We are going to increase the j, and j equals 3 now. So 2 equals 3. No, they're not equal. And this 4 is also finished because j took its maximum level. And we are saying if count equals to 1. No, count equals to 2. It means that we have a duplicate. So we are not going to print that element. We are not going to enter this if condition. We go up back here again. We reinitialize count to be 0. I equals 2 now. So count is equal, count equals 0 again. I equals 2, and j is going to take these values. So I is talking about this element which has the index 2, the third element, and we are going to compare 2 with 1, 2 with 2, 2 with 2, and 2 with 3 because we have two number 2's here. We are going to have count equal to 2 again, and when this inner loop is finished, we are going to have count equal to 2, and when this j loop inner loop is finished, we are going to jump here, count equals to 2, but here we are checking if count equals to 1. So we are not going to pass this if condition, so we're not going to print this element because it's a duplicate and not a unique element. We are going back up again here. Now we are reinitializing count to be 0, and I is incremented from 2 to 3. Now I is talking about this element, and j is talking about these elements. Okay, and we are going to compare 3 with 1, 3 with 2, 3 with 2. They are not similar, so this if condition is not true. We are not going to increment the value of count. However, when I equals 3 and j equals 3, both of them are talking about the last element, and they're equal, so we are going to increment the value of count to 1. Then this if is finished, this nested loop is finished because this j equals 3 in the last iteration. Then count equals to 1. We are going to check if it equals 1. Yes. Then print that element, the ith element, which is this one, because I equals 3 in the last iteration, and we are going to print this one. And we are not going to increment the value of I anymore because n equals 4, because we are having 4 elements in this array. We calculated the n here, and 3 was the maximum number that I could get. And now we are going to finish the program by printing a new line. So we printed out number 1 and number 3 in the output because they are the unique elements. So when I run the code one more time, we see again the same output. So here we learned how to use nested loops to find unique elements in an array. Thank you for watching. Hello everyone, welcome to this video. In today's video, we would like to find the sum of array elements. Here we are having an array called numbers, and it has these elements, 5 elements, 5, 15, 25, 35, and 45. We're going to calculate this value, 5 plus 15 plus 25 until 45, and we would like to know the sum of the elements of this array equals to what number. Because we want to do that, we are initializing a variable called sum equals to 0. Then we would like to calculate the sum of array element. We are having a for loop starting from 0, and as long as I is lower than 5. And the reason is that we are having the size of this array equal to 5, and I is starting from 0. So index 0 means the first element, then index 1, 2, 3, and 4. So I is getting from 0 until 4. It is covering all the elements of this array. Okay. Then in each iteration, we are going to have sum equals sum plus numbers I. So the ith element of the numbers array is going to be added to sum and assigned to sum. This exactly equals this one. Okay, so if you are familiar with this concept, you can either use this one or this one. It depends on you. So in the first iteration, I equals 0, we are going to have sum equals sum plus numbers 0. So the element with index 0 of the array numbers, the index 0 is talking about this element. So it means that we are going to have 0 plus 5. Why 0? We are saying sum initialized to be 0. So 0 plus 5, it means that we're going to have sum equal to 5. Okay, so sum equals sum plus the index 0 of this array means that 0 plus 5, 0 plus 5, sum equals 5. So we increment the value of I. Now I equals 1, sum equals 5 plus 15. Why 5? Because we are having sum plus now index 1, because I equals 1. Now index 1 is number 15, and sum equals to 5 because we calculated in the previous iteration. Therefore sum equals to 20 now. Then we are incrementing the value of I to 2. Sum equals 20 plus 25, and because the formula is the following, so we are having sum equals to 20, so 20 is here and 25 is the next element of the array with index 2, and this is going to have this result for us. Sum equals to 45, then I equals 3, we are having sum equals 45 plus 35, and 45 comes from here and 35 is the next element, so we are going to have sum equals to 80, then I equals to 4, sum sum equals to 80 plus 45. Therefore, sum equals to 125. Okay, so this way we calculated the sum of array elements. So when I run this code, we see that the sum of array elements is 125. So this is how we can find the sum of array elements. Thank you for watching. Hello everyone, welcome back. In today's video, we would like to find the maximum element in an array. Here is my array. It has 5 elements, 12, 45, 67, 23, and 9. And we would like to find the maximum element in this array. To find that, we know that this 67 is the largest number in this array, but we want to find it using C++. So when I run this code, we see that 67 is printed out in the output as the maximum element. In order to find it in C++, I initialize a variable called max to be equal to the first element of numbers array. This is just an assumption. Okay, this is just an assumption. We are going to check its validity. And we are going to iterate through this array, and we are going to we are going to compare all the elements of this array one by one with the max variable. And if any element in this array is larger than max variable, we're going to assign that to max variable. So here I'm going to start from 1 and we're going to continue as long as I is lower than 5. Why? The size of the array is 5 and we are starting from 1. So this one has the index 0, 1, 2, 3, and 4. So I is going to take values from 1 to 4. We're not starting from 0 because already number max, variable max equals to the first element of this numbers array. This is why we just start from index 1 and we're going to compare these elements with the max variable which equals to the first element. Okay. When I equals to 1, we are going to compare if the ith element of the array, which is 45, larger than max. So when I equals 1, we are going to say 45 is larger than 12. The answer is yes. So this statement is true. When this is true, we are going to assign 45 to max. So now max equals 45. Okay. Why? Because we compared the ith element. I equals to 1 means we are talking about 45. So 45 is larger than max. Max was 12. It was initialized here. And yes, this statement is true. Because this statement is true, we are going to assign that ith element of number array to max. So 45 is assigned to max. In the second iteration, I equals 2. We are checking to see if 67 is larger than 45. We're going to say if ith element of this array is larger than max. So the ith element when I equals 2, the index 2, we are going to have the number 67 is larger than max. Max was in the first iteration was updated to be 45. So 67 is larger than 45. Yes, this statement is true. We are going to enter this if condition. And then we are going to assign max to be equal to 67. Okay. Now I equals 3. We're going to say if ith element of number array, which is this one, then I equals 3, index 3 is talking about 23. 23 is larger than 67. Is it true? No, it's not true. False. This is false. This statement is false. Therefore, this condition is false. We are not going to enter this if condition this time. Then we increment the value of I one more time. So I equals 4 now. And when I equals 4, we're talking about this element, number 9. Number 9 is larger than max. And max is 67. And this one also is false. Therefore, we are not going to enter this if condition anymore. And this loop is also finished because I equals 4 was the maximum number that I could get. and we are going to print out the maximum element that we found. And the maximum element that we found was 67 in the last update that we had in our for loops. So here in this example, we learned how to find the maximum element in an array using for loops. And in order to do that, for review, I'm saying that we are having just an assumption in the beginning to assign the first element of this array to be equal to a variable called max, and then you go ahead and compare that max variable with any other element of this array. If any other element is larger than this max, assign that larger number to this variable and continue comparing. Okay, this is how we can proceed to find the maximum element in an array. Thank you for watching. Hello everyone, welcome back. In today's video, we would like to search for an element in an array. So here is my array with these numbers 10, 20, 30, 40, and 50. I would like to check if this element that we call key, this variable key, when it is equal to 30, we would like to see if 30 exists in this array or not. So we would like to see if there is an element in this array equal to this key or not. And we see yes, the answer is yes. But we would like to see how we can do it in C++. So when I run this code, we see that it says element 30 found at index 2. And this number 30, the index in this array is 2 because we start from 0. Here is the index. Okay, so index 2 has the same number in this array called numbers, and it equals the key variable. But how we can do it? We can iterate through all the elements of the array and then compare each element with the key variable to see if they are equal or not. And for that, we are assigning a Boolean variable found, and we are by default say that it is false. And if one element of the array equals to the key variable, we are going to assign true to this found Boolean variable because we found the answer. We're going to print the answer and we are going to break. We get out of this for loop, so we don't want to continue. Okay, so in order to do that, this is my array. This is the key variable I'm looking for, and we're having a Boolean, a variable called found. It is by default assigned to be false, and in case we find the element, we are going to assign it to be true. We are iterating through this array, starting from 0 until I is lower than 5, and then if any of the ith element of the numbers array equals the key variable, assign true to the found Boolean variable, and then cout print element 30. This is the 30, we're printing key found at index, and print I for us, and then break. So get out of this loop, and we are here checking if found is false. So it's not false, we are not going to execute this part of the code. If we couldn't find the key in this array, found variable was still equal to false, and we were going to enter this if condition saying that this element not found in the array, but we are going to have an example of that as well. So here we are going to have I equals to 0, I equals to 1, I equals to 2, I equals to 3, and finally I equals to 4. So when I equals to 0, when we are talking about ith element of numbers array, we are talking about this element. When we are saying 10 equals to key is 30. Okay, 10 equals to 30, no, not entering this if condition, increment the value of I. 20 equals to 30, no, increment the value of I. 30 equals 30, yes. So when I equals 2, we are having the ith element of this numbers array equal to 30, and 30 equals the key, which is also 30. Therefore, this condition is true. We are going to enter this part. We assign true to the found Boolean variable, and we print that this element 30 found at index 2 because we were in the third iteration with index 2, and we are going to break so we get out of the loop. So when I run this code, you see that it says element 30 found at index 2, exactly as we wanted. But here, if I have some number like 14 and it's not equal to any of the elements in this array, so what is it going to do is like the following. When we are having the for loop, we are saying 10 equals 14, no. 20 equals 14, no. 30 equals 14, no. 50 equals 40 and 40 equals 14, no. Therefore, we were in this for loop, we were not entering this if condition, and this for loop is also finished. And here also, the found variable remained false. When it remained false, we are having this message element 14 not found in the array. So the way that we are going to have this to be activated is again here. So I'm going to review. We are going to loop again over the array numbers. We are going to compare 10 with 14, 20 with 14, 30 with 14, 40 with 14, and 50 with 14. Neither of them are equal. So this if condition is not true in any of the situation, and this part is not executed, and this for loop is finished, and found Boolean variable remained false because we didn't enter this if condition, okay? And it remained false, so we say found Boolean variable is false. Yes, it's false because we are having this mark here. It means that it is false. Then we are going to say element 14 not found in the array. So this is how basically we can search for a specific element to see if it exists in an array or not. Thank you for watching. Hello everyone, welcome back. In today's video, we would like to write a program to find the largest 3 elements in an array. In order to do that, here is my array, and the size of this array is 6. So we are having 12, 13, 1, 10, 34, and 16. And we are using this formula to calculate the size of the array. And we know because the array is not so big, we know the size of it, but for the sake of simplicity, we are going to calculate the size. And then because we are looking for the largest 3 elements in this array, we are going to say if the size is lower than 3, say that the array must have at least 3 elements, okay? Then we are going to use the sort function to sort the array. And in order to use the sort function, we need to include this header algorithm. In the sort function, we are going to type down the name of the array before the comma. So there are 2 arguments to take care of. Before the argument, we need to type down the name of the array. After the comma, we need to type down the name of the array plus the size of the array. So when I type down the name of the array, here it is going to assume that we are going to start from the index 0 of this array. Okay, so this is the starting point. So sort function, starting point, then ending point. Okay, so before the comma, we're going to have the starting point. After the comma, we're going to have the ending point. Then this name of the array that is written, the compiler in the sort function is going to translate it to start from the index 0 of this array called ARR. And then we are having the comma, and then we would like to have the ending point. We are going to have 0 again because we are having the name of the array plus the size, and plus size is the 6. Okay, number 6 is the size. We calculated the size. This is the size, and we calculate the size with using this formula. Okay, so now we see that the number 6 is the ending point. But here, when we are using the sort function, starting point is inclusive and ending point is exclusive. Okay, so here I'm typing down start from index 0 and end at index 6 exclusive. Okay, so here is my indexing for this array. This is 0, index 0, 1, 2, 3, 4, and 5. Although we are having 6 elements, indexing in this array starts from 0 until 5. So in the starting point, we are having 0, so index 0, and it is inclusive for the starting point. And for the ending point, it is exclusive. Therefore, we are writing down 6, so we make sure that it continues until index equals 5. So it is going to basically sort this array from the beginning until the end. After doing that, we need to access the last 3 elements. And in order to access the last 3 elements, we can use this cout function saying that the largest 3 elements are, this is the message. And in order to access the last 3 elements, we type down the name of the array, and then we type down the size -1, -2, and -3. This way we are going to access to the last 3 elements of the array. So when I run this code, we see that number 34, number 16, and number 13 are the 3 largest element in this array. So when I do the sorting, now my array would look like something like this. It is going to start from the smallest number and it is going to continue to increase. So 1, 12, 1, 10, 12, 13, 1, 10, 12, 13, 16, and 34. Yeah, okay. So after sorting the array is going to look like this. When the array look like this, we know that the 3 largest elements are the 3 last elements because we just sorted the array. Therefore, we would like to access these 3 elements, okay? In order to access them, we type down the name of the array, and then we type down size -1 to access this one, size -2 to access this one, and size -3 to access this one. So when we are using the minus sign here, when we are typing down size -1, it means that so the size was number 6, so we calculated the size equals 6, and when we type down 6 -1, it is the last index, so we are calling the element with index 5 from the array, which is now after sorting 34. Okay, so here is our indexing 0, 1, 2, 3, 4, and 5. Okay, and size equals 6. So 6 -1, the index will be 5. So I'm calling the index 5 of this array, which is this number. Then I'm calling the 6 -4. 6 -2, 6 -2. Therefore, the answer is 4. And I'm calling this element of the array. And then I'm having the 6 -3, which leads me to index 3, which has this element, which is the third large element in this array that we provided here. So here it's like I'm typing down array 6 -1, which will be 5 in the end. Array 6 -2 will be 4, and array 6 -3 will be 3. So I'm calling the element with index 3 in this array, element with index 4 in this array, element with index 5 in this array. Thank you for watching. Hello everyone, welcome back. In today's video, we would like to write a program to find the smallest element missing from a sorted array. So here is my sorted array, 0, 1, 2, 6, and 9. And we see that there are some elements missing from this array. 1, 2, 0, 1, 2, 3 is missing, 4 is missing, 5 is missing. Then we are having 6 and 7, 8, and 9. Okay, so in the original array, we are having these numbers. So 0 is there, 1 is there, 2 is there, 3 is not there, 4 is not there, 5 is not there, 6 is not 6 is there, so I'm going to remove it, and 9 is there, I'm going to remove it. So these are the missing elements from our sorted array if we want to have an array from 0 to 9. Okay, and we would like to write a program to find the smallest element missing from this array, and the smallest one is number 3. Okay, so we are missing number 3 here, and we are looking for number 3. Here I'm calculating the size of the array, then I call the find smallest missing function, and I pass 2 arguments, the array and its size. So this function is getting the array and its size. It is iterating from I equals to 0 as long as I is lower than size, and in each iteration it is checking to see if the element of the ith element of the array is not equal to I. Okay, so what it does actually is the following. So here is the index of the first element, here is the index of the second element, here is the index of the third element, here is the index of the fourth element, here is the index of the fifth element. We are checking to see if 0 is not equal to 0 here. Okay, because when the index and the element, they are equal, it means that we are not missing that number. We are investigating index 0 and we are having the number 0. So we are not missing number 0. And in order to check if we have number 1, I'm having 1 equal to 1. Okay, so we are not missing number 1. 2 equals to 2. But then number 6 is assigned to index 3 because it's the fourth element. And here we could have number 3 to be equal to number 3. Okay, index 3 for number 3. But we are having index 3 for number 6. So number 3 is being missed here in this place. So this is how we are going to find number 3. We are going to check each index with the corresponding element to see if they're equal to or not, because our array starts from 0 and it is a sorted array, and indexing in C++ starts from 0 as well. So indices must be equal to the elements, and when they are equal, it means that we are not missing that numbers, because 0 is there, we are having index 0, 1 is there, we are having index 1 for the number 1. So for number 2 the index is 2, but for number 6 index is 3. Therefore number 3 is not there, it is the place for number 3. So we are missing number 3. This is how we are going to trace number 3. So if the ith element of the array, for example this element of the array, is not equal to its corresponding index, which is 3 here, okay, so 6 is not equal to 3, we find that that number is missing. So this number 3 is missing, so return that number for me. This function is going to return an integer, so it is going to return number 3, and then the returned number 3, or the output, let's say, is assigned to the missing variable, which is of integer type, and we are showing this message, the smallest missing element is, and then this is the name of the variable. So when I run this code, it says the smallest missing element is 3. So if I change this, for example here, okay, just imagine that we are having now an array with this format. So 0, 1, 2, 3, 4, and 6, and 9. So index 0 for number 0. Index 1 for number 1. Index 2 for number 2. Index 3 for number 3. Index 4 for number 4. But index 5 for number 6. So number 5 is being missed out here. We should have had number 5, but we don't have it. We are missing it. Therefore, now in this example, we are going to have number 5 being missed out. So when I run this code, when it is run, it shows that number 5 is being missed in this sorted array. So this is how we can find the smallest missing number in an array. Thank you for watching. Hello everyone, welcome back. We would like to write a program to count all the vowels in a given string. Here is my main function. We are declaring one variable called input string. It's of a string data type. We are showing this message, enter a string. Then using the get line, we are storing whatever the user is entering in the input string. Okay. Then we are calling this count vowels function, and we are passing our string to this function as the argument. Then this is the name of the function, count vowel. It is going to return one integer value, and it is going to get one variable in the string data type, and it's a call by reference, so we can directly work with the original variable, and we use the keyword const, let's say, in order to make sure we're not doing any modification to the variable. Although we're using the call by reference, so we can do some modification, we just do it because of the efficiency of the memory, and we don't want to change it. Then we are having a variable called vowel count initialized to be 0. And then we are going to iterate through this string. So for any character ch in the string called str, if this iterating variable ch equals to small, lowercase or uppercase, let's say a, lowercase or uppercase e, I, o, or u, if ch equals to either of them, we are using AND operator. Either this one, or this one, or this one, or this one, or this one. If any of these situations happens, increment the value of vowel count, and then after finishing this for loop, just return the vowel count value for us. So whenever this function is called, this is going to find the number of vowels and return us the number of vowels, and the number of vowels is going to be assigned to vowel integer, and then we are going to show it in the output saying that the total number of vowels in the string, and then show the message in the output that, for example, our string has 2 vowels, etc. So I type down the string. It says type down your string. As you see, I would like to type down Reza, and Reza has 2 vowels, E and A. So when I run the code, it says the total number of vowels in the string is 2. So when I run the code one more time and I type capital E, for example, it says the total number of vowels in the string is 2, because we said either lowercase or uppercase. It is going to consider both cases. So it's not a sensitive case program, because we considered both options. So when I run the code one more time, for example, I type down Reza and Shaheen. It says the number of vowels in this string is 4. So we are having 1 E. So this is 2, this is 3, and this is 4. So basically, this is how we can count the number of vowels in a string using C++ programming. Thank you for watching. Hello everyone, welcome back. We would like to write a program to compute the sum of all elements in an array using pointers. Here is my array. It has 5 elements, 10, 20, 30, 40, and 50. So we would like to have a variable called sum, which equals 10 plus 20 plus 30 plus 40 plus 15. So we would like to know the sum of all elements in this array. What is that number? In order to do that, I calculate the size of the array. Then I define an integer pointer ptr equals assigned to be pointing at the first element of the array arr. Okay, so integer pointer ptr is pointing at the first element of the array because array is assigned to it. Then we are having a variable called sum, which equals to 0, which equals 0. So we are initializing it to be 0. Then we are going to iterate through this array, and we are going to use the pointer to calculate the sum. In order to do that, here our iterating variable I starting from 0, and it is going to continue as long as it is lower than the size of this array, and the size of this array is 5, and we are going to continue as long as I is lower than the size of the array, and the reason is the indexing in C++ starts from 0. So I starts from 0 and the size is 5, So we don't have any element with index 5. So this is why the maximum number I can get is 4, and 4 is the index of the last element. Therefore, we are going to start from 0 and end at maximum 4. So as long as I is lower than 5, or the size of the array, and we are going to increment the value of I by 1 unit in each iteration. Okay. In each iteration, we are having sum plus equal pointer PTR. Okay, it means that sum equals sum plus pointer PTR. Okay, and we know that this equation equals this equation. So they are the same. It depends on you. Which one you're more comfortable with, go ahead and choose that. But I type it down in this way, so because I think it's more convenient to explain on this way. Okay, so when I equals 0, we are having sum equal sum plus PTR, pointer PTR. So we are having sum which is 0 plus 10. Why we are having 0 plus 10? Because sum equals sum plus pointer PTR. So sum equals 0, we initialize it to be 0. And then we are having pointer 10 because pointer is pointing at the first element of this array. Okay, so now sum equals 10. So this is the output that we are going to get in the first iteration. Then what we are doing here is actually we are calculating the sum in each iteration, and then we are having PTR plus plus. So we're doing this now. Pointer is not pointing at the first element anymore, but pointing at the next element. So we are moving the pointer one element ahead. So now pointer is pointing at 20 by doing this. Okay. Okay, now in the next iteration, I equals 1, we're going to have sum equals 10 plus 20. How? So we have 10 from the previous iteration. We calculate the sum because sum is in the formula, and then pointer PTR is pointing at the second element. So sum equals 30. Okay. After that, we are incrementing the pointer. It means that we are moving the pointer to next element. So now the pointer is pointing at this element, and I has incremented to 2. So sum equals 30 plus 30. Why? The first 30 comes from the sum, and the second 30 comes from the pointer, which is pointing at this element now. So sum equals 60 now. Next iteration, we are going to have I equals 3. We are having sum equals 60 plus 40, because now pointer after the next iteration, we move the pointer to the next element. So now it is pointing at this element. So 60 plus 40, sum equals 100. And in the last iteration, I equals 4, and we move the pointer as well. So now pointer is pointing at this one. I equals 4, sum equals 100 plus 50. Therefore, sum equals 150. And this 100 comes from here, and this 50 comes from the pointer pointing at this element. And this was the formula. Based on that, we calculated all the iteration. So in the last iteration, when I equals 4, we are having the sum equals 150. So the sum, the result of this was 150, and we used pointer to calculate it. So now this for loop is finished. Then we are showing this message in the output. The sum of all elements in the array is, and then we are having the sum here being printed out in the output. So when I run this code, we see the sum of all elements in the array is 150. So this is how actually we can compute the sum of all elements in an array using pointers. Thank you for watching. Hello everyone, welcome to this video. In today's video, we would like to write a program to check whether two characters appear equally in a given string. So let me run the code. We are having a code. When I run, it asks me to enter a string. I would say this is my string Reza. It says enter the first character, I would say R, enter the second character, I would say A. It says the characters R and A appear equally in the string. It means that we are having one R and we are having one A. If I run the code one more time and I type down result with double A, this time the first character is R, the second character is A. It says the characters R and A do not appear equally in the string. Why? Because we are having one R, but we are having two A's. So we would like to write a program to check whether two characters appear equally or not. In the main function, we declare one string called str and two characters. First, we show this message to the user, enter a string. Using getLine, we are going to store it in our string str. Then we ask for the first and second character. We are going to store them in ch1 and ch2. Then we are having an if-else condition. We check if this condition is true. We are going to show this message, these two characters appear equally. Otherwise, they do not appear equally. But what is this condition? This condition is a call of a function called are characters equal, and because they are in the parentheses of the if condition, I assume that it is going to return a boolean, either true or false for us, but we are going to see and check it out. And this function accepts three arguments. The first argument is the string that we have, the second argument is the first character, the third argument is the second character. So when we are calling this function with these three arguments, the compiler starts executing this function. So this function, the name is are characters equal. It's of Boolean type, so it is going to return either true or false as we expected. And we see that there are three arguments in the parentheses separated by a comma. So the first argument is a string. We are having a call by reference, so we are directly accessing the original string. Then we are using the const keyword to make sure that we are not doing any modification while working with the string. The second argument and the third argument are both the characters that we have, and they are of char data type. Then we are initializing two variables, two integer variables called count1 and count2. They are equal to 0. In order to understand if ch1 and ch2 both appear equally in the string, we're going to first of all loop through the string. So we are writing a for loop saying that for each character ch that is going through the str string, if my iterating variable ch here equals ch1, the first character, then increment the value of count1, which is initialized to be 0. And also if ch equals to ch2, which is the second character, increment the value of count2, which was initialized to be 0. For example, if my string is Reza and ch1 is R, ch2 is A. Okay. Now we are iterating through this string, and we are going to have 4 iterations because there are 4 letters in this string. So in the first iteration, ch equals R. Okay. And then we are checking in this condition, we are checking if ch equals ch1. So ch equals R and ch1 equals 1. So we are going to increment the count 1. So count 1 equals 1 now. Okay, we incremented by 1 unit. And then we are going to see if ch equals ch2. Ch in this iteration is R, ch2 is A. So they are not equal. So we are not going to increment the value of count2. Then we go up, we are having the second iteration. Now this time ch equals E because we are iterating through the string. So now we are having the second letter of this string. We check ch now with ch1. So E equals R. No, so we are not going to increment the value of count1. then ch equals ch2, so e equals a, no, so we are not going to increment this value as well. So we go up again, and we are having the third iteration. This time ch equals z, and we check to see if z equals ch1, which is r, no, we're not going to do anything. Then we check if ch equals ch2, z equals a, no, so we're not going to do anything again. So we go up, and we are having the last iteration, which is the fourth iteration. Ch equals a, and we are going to say a equals r, no, a equals a, yes. So in this part, the condition is true, so we are going to increment the value of count2 equals 1. So this for loop is finished. Now at the end of this function, we are going to check if count1 equals count2. So count1 is 1, count2 is 1, so it means that r, the ch1, appeared one time in Reza string, and also a, which is the ch2, appeared one time in the string Reza. Therefore, they appear equally. So now that they appear equally, we are checking this condition. See, count1 equals count2. If this statement is true, the function is going to return true. Otherwise, it is going to return false. And when the string is Reza with 1a, the statement, this condition is true. Okay, it is going to return true here, and the condition is true, so we are going to enter this part and show that both characters appear equally in the string. However, if we are having a string called Reza with double A, we are going to have the fifth iteration as well. Then ch equals again a, and we are going to check these two if conditions. So cha equals ch1 r, no. Ch equals ch2a, yes, this is true. So we are going to have count2 equals to 2, because we are going to increment its value again. Okay, so count2 updated to 2, count1 is still 1, and this for loop is finished because we are at the end of the string and we iterated through all the letters. Now in the end, we are checking to see if count1 equals count2. Count1 equals 1, count2 equals 2. So this condition or this statement, let's say it's not true, it's false. So this function is going to return false, because it's a Boolean function. It is going to return either true or false. So it is going to return false. When it is false, when this condition is false, this if is not activated, so we are not going to execute this part, and we are going to jump into the else part. Okay, this part is going to be executed only if it's true. So it's false, it is going to jump into the else part, and it is going to say the characters ch1 and ch2 do not appear equally in the string. So this is how actually we can check to see whether two characters appear equally in a given string in C++. And we can test it with different strings, with different names, for example, and we can compare the characters that appear in a sentence, in a phrase, for example, or just only in a word. Thank you for watching. Hi, welcome back. In today's video, we would like to write a program to find the factorial of a given number using pointers. What do we mean by factorial? For example, the factorial of number 2 is 2 multiplied by 1, which is 2. But the factorial of number 3 is 3 multiplied by 2 multiplied by 1 equals 6, for example. So we would like to do that in C++. For example, when I run this code, it says enter a number. I would say 3, for example. It says factorial of 3 is 6. And if I, for example, run the code one more time and I type down 5, it says factorial of 5 is 120. So we would like to write a program that do this work for us. Here is my main function. We are having two variables called n and fact. We're going to ask the user enter a number, and whatever the user is going to enter, we are going to store it in n. So this is the number that the user wants to have the factorial of. Then we are checking to see if n is lower than 0. If n is lower than 0, we are showing this message saying that factorial is not defined for negative numbers. Otherwise, we are going to call the function called factorial, and we are going to have two arguments being passed by reference. Okay, so the first one is n and the second one is fact, and this n is the user input, and fact we are going to work with it inside the function, and we are passing them by reference here. So we expect to see arguments in the function as pointers. So here is my factorial function. It's of void type, so it's not going to return anything. It is going to just simply calculate some stuff for us here. Then we see that here in this function, we are having two arguments, for example, integer pointer num and integer pointer result. So the address of this n is going to be assigned to integer pointer num, and the address of the fact is going to be assigned to the integer pointer result. And then we are initializing result to be 1. Okay, so we are dereferencing the pointer to initialize it to 1. Then we are going to have this for loop here. So this for loop is going to start from 1. As long as this I is lower than or equal to the pointer num, we're going to continue this for loop. For example, if the user enters, for example, n equals, for example, 3, so the pointer num is 3. Therefore, I is going to take values 1, 2, and 3. Okay, and in each iteration, for example, when I equals 1, let me just type down this part first. So we type down result equals result multiplied by I. This equation exactly equals this one, but I type it down in this way to make it easier for explanation. So we are going to have, when I equals 1, we are going to have results equal, so 1 multiplied by 1. Why? The first one is from this dereferenced result, which is initialized to be 1. And this one comes from the I, which is in the first iteration, therefore it's 1. Therefore, we are going to have results equal to 1. Okay. Then when I equals 2, we are going to have results equals 1 multiplied by 2. Sorry, here I equals 2. So in this case, the results comes from the previous iteration equals to 1. Then we are having I equals 2, which is here. Therefore, we are having the results equal to 2. Okay, and finally, in the iteration when I equals 3, we are going to have results equals 2 multiplied by 3. Why 2? 2 comes from this last iteration of dereferenced result. So this is 2, and 3 comes from the I. This is the third iteration. So this was the formula, right? Dereferenced I, dereferenced result multiplied by I. So dereferenced result is 2 from the last iteration, and multiplied by I equals 3. So the results equals 6. Okay, so we calculated the results to be 6. Okay, so this is the output actually of this for loop. So when we call this function is going to calculate this calculation for us, and then we are going to simply store whatever that the result is. The dereferenced result is our second argument, right? This is the second argument, and the second argument was here named fact. And finally, we are going to first call this function, and then showing this message factorial of n is, and we are going to print out this fact in the output. And because we are passing the address of this variable to this function, and this function has an integer pointer result, so it is working exactly with the same variable. So any modification that is done here in this for loop with the result, we are going to see it also in the fact as well. So we are going to then print in the output. So when I run the code one more time, I type down 3. So let me show you how it works. We are calling the function. Here we are entering a number 3, so we are storing in n. 3 is lower than 0, no, so we jump into the else part. So we are calling this factorial with the address in which this number 3 is stored, so the address of n and the address of this variable fact. Okay, then this function is called. We are initializing this dereferenced result, or let's say result for the sake of simplicity, equals to be 1. So fact, which was the second argument, is assigned to be 1 now. Then we are having a for loop. In each iteration, we are updating this result variable as you see it here. Okay, and because we passed it by a reference, whatever the modification that is done inside this function, it is going to impact the original variable as well, because we are directly working with the variable. Then in the end, we calculated the last iteration, and result equals to 6. And finally, because result was the second argument, therefore it was working with this variable. Yes, and we are going to show after the call of the function, after all the calculation is finished, we are going to show this message saying that okay, factorial of n, which was 3, is 6, which was the calculation here that we did in our program. Thank you for watching. Hello everyone, welcome back. In today's video, we would like to write a program to swap two numbers using pointers. Here is my main function. In the main function, I'm having two variables, x and y. And we are asking the user to enter x and y, so we are storing them respectively. Then we are calling the swap function, and we are passing the addresses of these two variables to the swap function. Okay, and here we are having integer pointer a and integer pointer b as arguments. So integer pointer a has access to the address of variable x, and integer pointer b has access to the address of variable y. Then in order to do the swap, what we are doing here is the following. We are creating a new variable that is called temp, and then whatever that is inside a, we are assigning to temp. Whatever that is inside b, we are assigning to a, and whatever that is inside temp, we are assigning to b. So let me illustrate it with an example. Imagine that x equals 10, y equals 20. And in this case, when x equals 10, it means that a equals 10. Okay, because we are putting the address of x into the integer pointer a, and the same goes with b and y. So, and we would like to swap them. In order to swap them, I'm having a variable temp, and we're assigning 10 to this temp variable. Then whatever that is inside b is being assigned to a. Whatever that is inside b is being assigned to a. So a equals 20 now. Okay. Then whatever that is inside temp, we are assigning to b. So b equals 10. As you see here, a was equal to 10 and b equal to 20. Now a equals to 20 and b equals to 10. So we used a third variable in order to swap these two numbers. And when the work is done, because we were having access to the address of these two variables, so we were using pointers here, we directly modified the original variables. So now we are saying after swapping x and y are this. So let me also have this message here before swapping x and y. So before swapping, we are printing x and y, and after swapping also we are printing it out. So when I run this code, it says enter two numbers. So here is the message, enter two number. I would say 10 and 20. It says before swapping x equals 10, y equals 20. After swapping x equals 20 and y equals 10. So in this video, we learned how to swap two numbers using pointers. Thank you for watching. Hello, welcome back. In today's video, we would like to write a program to print an array using pointers. Here is my main function. I'm having my array here. It has 5 elements, 10, 20, 30, 40, and 50. And we would like to print the array's element. In order to print that, we show this message, array elements, and then we call this print array function, and we pass two arguments. So the first argument is the name of the array, and the second argument is the size of the array, which is 5. Okay. Then this print array function, this is the name of the function. This is the of void type. It means that it's not going to return anything for us. And then we are having two arguments in the parentheses. So the second argument is integer size, which is going to take the value 5, which is the size of the array that we're going to work with. And the first argument, which is separated by a comma from the second argument, is an integer pointer called ARR. And now, because we are having this as the first argument, it is pointing at the first element of this array called ARR. So now this pointer is pointing at the first element of this ARR array. In this function, in order to access this element of this array, we need to have a for loop. We are going to have a for loop with iterating variable I starting from 0, and it is going to continue as long as I is lower than size. When I equals 0, I equals 1, I equals 2, I equals 3, and finally I equals 4. We see that we are going to iterate through different values of I from 0 to 4. So 1, 2, 3, 4, 5. All the 5 elements are covered. All the 5 elements of the array are covered. But we are starting from 0. This is why I is going to continue as long as I is lower than the size. And size is 5. Okay, size is 5. So because we are starting from 0, the first element index is 0, the second one is 1, the third one is 2, the fourth one is 3, and the fifth one is 5. And in each iteration, we are going to print the element of the array. For example, when I equals 0, we are going to have a pointer of the array ARR plus I. So I equals 0. It means that this pointer is going to point to the first element. Okay, by default, the pointer ARR was pointing at the first element, and we are moving it with 0 unit. So it is going to stay the same at the same place, and it is going to still point at 10. In the second iteration, we are having ARR pointer plus 1, because I is 1. Yes, I is 1, so we are having I plus 1. So we are saying that, okay, this ARR pointer is pointing at 10, but I would like to add 1 unit. I would like to move it by 1 unit. Okay, so now it is moved and pointed at this second element. I'm saying it one more time. Here, by default, this array is pointing at the first element, which is 10, and we would like to move it by 1 unit. So when it is moved by 1 unit from 10, it goes to 20. Now it is pointing to 20, okay? It is going to print 20 for us now. Previously, it was going to print 10 for us. Then we are having the pointer ARR plus 2, and it is going to continue for the other ones as well, plus 3, plus 4. So it means that here, this pointer is pointing at this element, and we would like to move it 2 units, okay, by 2 units. So 1 and 2. So now it is pointing at this element, so 30. Then it is going to print 40, and 50 as well. So the reason why we are typing it this way, because we first want to move the pointer, then use the star. If I type it like, for example, pointer ALL plus I means plus 0 or plus 1 plus 2 plus 3, this is going to point at this number, which is 10, and then is going to be adding 3 values to 10, so the result will be 13, sorry. So this is why we are not typing it this way. We would like to type it in parentheses to first decide the pointer is going to point at which element, then have the star, okay? Then have the dereferencing, let's say. This is why. So when I type it this way, it means that the pointer still pointing at the first element, and we are adding 3 units to the first element, meaning that it will be 13, okay? But here, when I type it down this way, it means that I am moving the pointer from the first element 3 units, which will be here. So it is pointing at this element now, and then I'm dereferencing it. So I'm putting the star. This is the important thing that we need to be careful about. So when I run this code, it says array elements 10, 20, 30, 40, and 50. So this is how we can access the elements of an array using pointers. Thank you for watching.